Good.
Hello, I am Kush Kumar Patel, and today is my assignment of my plant disease classification project developed for the machine learning module. The module is implemented using artificial neural network architecture, unlike CNN, which are commonly used for image tasks. This project explores the potential of fully connected ANN for classification RGB leaf image into four planet disease category. The dataset is a folder structure which allows me to use Keraflow from directory to automatically load and label the images. The dataset was split in 80 by 20 into training and validation set. All images were resized 64 by 64 pixel and normalized 0 to 1 scale. Here we can see that we import the library, the ASNP, ASPLET, Chevron, and here we can see the SN. I say the recall is a 1 by 255 validation split into 0 to 2, and we found that the 33027 images belong to the 16 classes, and found 8249 images belong to the 16 classes. Now we can see that the flattened image data convert to the flat array. We can use the data generation features label and we can see the model architecture. The model is compiled using the Adam optimizer with the learning rate of 0.0005, and the training runs from 30 epochs with early stopping enabled to monitor validation loss. As you can see here, training stopped early at epoch 11 when no further improvement was detected. This is the training phase. We can see the carriers callbacks and import early stopping, and this is the chart of the ANN constructor. We can see that total params is 3188176. It's 12.16 MB. Trainable params is 3188176. It's 12.16 MB, and non-trainable params is 0 and 0 MB. We can see the clearly in this. We can use the all the data. In training phase, we can import the early stopping and everything. This is the visualization matrix. To evaluate performance, I use the accuracy F1 score and confusion matrix. Here is the classification report, and as you can see, the model achieve moderate performance across all classes. The confusion matrix show how well the model between the classes. The training and validation curves all indicate stable convergence without overfitting. We can see the two charts. One is accuracy per epoch and one is a loss per epoch. Both both chart is very different position, so we can clearly detect this. And in confusion matrix, we predict the value. And confusion matrix, we can see that the clearly chart. It's predictable chart. This one is a actual chart, and this one is predictable chart. And we can see that the 4127 is the highest in the chart. This is the report. We can see that the paper bell metrical spot is precursion 0, recall 0, F1 score 0, and support is 1999. Paper bell health is precursion, recall, and the F1 score 0, and support is 295. Plant village is precursion is 0.50, recall 1, and the F1 score is 0.67, and support is 4127. We can see that the tomato leaf model is 0 precursion, 0 recall, and the 0 F1 score, and the support is 190. We can see that the accuracy F1 score is 0.50 and support is 8249. Marco average is 0.09 for precursion, 0.07 for a recall, 0.05 for a F1 score, and the support is 8249. Weighted average is a precursion for 0.30, recall for 0.50, and F1 score for 0.34, and the support is 8249. To address class imbalance, I use the class weighted during training and apply the dropout to prevent overfitting. This project demonstrates that even with the simple ANN, it's possible to classify plant leaf disease with the responsible accuracy. While not perfect, the work meets the assignment aims building an effective, interpretable machine learning pipeline while maintain a simplicity. And this is my work and the outputs. Thank you.